Hi, welcome back to PyHacks as part of the Hutsons-Hacks tutorials. Today we're going to be following on from our previous lesson where we looked at lists. Today we're going to look at looping through those lists and creating list comprehensions. Okay, so let's launch Spider or whatever code editor you're working with, even a Jupyter Notebook, and let's get into the code. So bringing back Spider, and I'm just going to run these lines again to make sure we've got our variable editor ready. So I've got everything I need from the previous tutorial. So if you've not got this far, what I'd recommend is you go back and watch the previous tutorial, or ultimately download the code from the associated GitHub and get up to speed. So the next thing we're going to do is we're going to do looping through lists. Lists. Tongue twister for me, this one. Okay, so what we're going to say when we set up a loop, when we loop through lists, it's always best to use for loops because while loops are useful in Python, but for loops tend to be more used with lists. So you can call it iterator. I is normally used. I'm going to call it litem. So for list item in. So we've got programming languages. So for each item in programming languages, do something to it. So all we're going to do at this stage is we're going to print a nice statement. So the current programming language, we're going to use placeholders here. So a placeholder is basically reserved for something we're going to pass through to the format statement at the end. So at the end of the prints, at the end of this, we're going to go dot format, and the item we want to format is our list item. So for every item, list item as it's looping, so for every individual item, print that current element out to the console. So what we need to pass into this is the L item. And I'll show you how you can format those later on. So if I now run these lines, quite a simple loop, press F9, you can see now it's giving me a nice informative output. We could actually make this look even more crisp and put something like a message, like placeholder. Let's run that again, F9. So a message, I've got the current program language is Python, the current program language is R, C, SQL, JavaScript. So that's one way we can loop through it, and that's looping through a list of actual values, so nominal values, categorical values. The way that you'd do it if you wanted to pull back the index is use a range object. So we're going to use a range object. So we're using the same iterator. It's a variable. It can be called whatever you want, my iterator, whatever. We're going to use a range function, so a range of values. So here what we want to do is have a termination point. So we want to know where to go. So we're going to use the lang command because that's going to return me a nice index value in terms of the size of the list. So len, programming languages. Remember, indentation in Python is really important. So it always indents for you in Spider, which I really like. And this time we're just going to do a simple print of the index. We could actually, let's do the same. The index of the L item is, and then we're going to use this format. Oh, we've got to create a placeholder. We use this format command at the end. Format. So every time this goes through now, what it's going to drag back is the current numerical or integer index. The index of L item is 0 at this one here, 1, 2, 3, 4. So it gives you the index numbers as well. Okay. So now we're going to show you how to loop through numerical lists, and what we're going to do is perform a calculation on that list. So I've been a coder for a long time, doing data science, etc., creating many machine learning models, but I always make millions of mistakes. So as you start, the mistakes probably in the hundreds, let's say thousand to exaggerate. Then as you get better, it starts to reduce a little bit. Then as you get better, it starts to reduce. You still make mistakes, but you start to make less and you make them more quickly. So what I'm now going to do is I'm going to define an empty list at the moment because I'm going to store some values later on. I'm going to call this yearly coding errors. I'm going to call this what the reality probably is. So to set an empty list, it's just those brackets there. So I've got a filled list, these yearly coding errors. I'm going to reserve this empty list because I'm going to do a calculation inside the for loop. For, and this time I'm going to use I in yearly, so the list yearly coding errors. As you can see, if you wanted to have a look what was in that list, you'd be able to see it up in this variable editor here. I've not actually created the list yet, so let me just F9 that. There's yearly coding errors, and then we're going to have this reality one as well, so this empty list. So pressing F9 on both of those returns both of those lists. So for I in yearly coding errors then, what we're going to do is we're going to set a variable called reality. And this variable is going to do an intermediary calculation. So I'm going to cast it to an int because I think it's going to return a floating point value. So I'm going to do cast to an int, and what I'm going to do is times it by 25%. So I'm actually going to uplift all these values by 25% because I think actually I'm being probably conservative. So that all that line says is for each iteration, so for each item, times it by 25%, and then cast it to an integer to make sure that there's no floating decimal points. So now I've got this reality variable. It makes it pretty simple because every time it goes through, I'm going to now reference reality instead of the I, because the I is another calculation that I'm looking for. So it's using I in that calculation. So for every time it goes through, it's going to create this variable reality, and it'll always terminate on the last variable. But because I want to create multiple items, I'm going to append it to our yearly coding errors in reality. And to append a list, you use the method append. And I'm going to append the variable reality that I've just created. So the 25% uplift on the original list items. So now we're going to create a print. The user said, me, he has a yearly coding error of, and it'll print it every time. So I'm going to create a placeholder there. Then we use a new line special character. And I'm going to put something like, so this will break over 2 lines. That's why we put this hash n here. In reality, it is more like, and then we're going to go put another placeholder here. And then I'm going to end it with errors. And in the format statement at the end of the list, I'm going to have to pass 2 values in. So the 2 values I'm going to pass to that are the initial iterator I and the variable reality. And because one's going to be potentially a floating point, what I'm going to do is use a special string command. So comma 0, so point, decimal place, 0f. So that means 0 after the number itself, cast it to a, when printing, to a 0 decimal place if it's 2 or 3. We know that not be the case now because we've converted it to an integer, but it's always worth checking when you do the print. So let's run these lines. So as you can see in my console here, we've got this yearly coding error reality list that's now been filled because it's been appended to this reality. We've got these values, the original yearly coding errors, and then they've gone up by 25% each value. I mean, I could have gone really wild and done a to the power of 1.25. Let's do F9 and see what that does to it. Got a lot more now I'm doing to the power of. Let's keep it at times. And let's run that back again, F9. Okay. This F9 will only apply to Spider. If you're working with Visual Studio Code, then it's probably Control and Enter. With Jupyter, I think the same is true to evaluate each cell, so that'll still work. Okay, so that's how we loop through those numerical lists then. But what we could do, and this is where, as you can see, this is not a really complicated loop. You'll see loops with lots more code than this. If I wanted to just create the lists with all these calculations, so this raising it to adding a weight of 25% to each of those values, I could use list comprehension. And I'll show you how this works shortly, but the general form is, so what it does is it takes an existing list and performs expressions on that list and iterators like this. And it also has inbuilt if condition functionality. So if a certain condition is true, it will return a subset list. So let's do a couple of these in practice based off the original raising my coding errors by 25% example. So I'm going to create this yearly coding, let's call it yearly list comprehension coding reality. So I'm going to perform this part again in list comprehension. So, sorry, equals. So I'm going to create an empty list. And then first of all, your expression goes first. So my expression is this. So I could drag and drop this into it. So I could go int then. And then I'm going to go for I in, and then what we did before, for I in yearly coding errors. And then I'm going to close that off. So this is one without an if condition. So if you just want to iterate over everything and you don't want to have conditional statements that evaluate true or false, this will essentially apply it to every value in that list. So we'll see the same output as what we did in the loop of over 1, 2, 3 lines in one. So this is going to perform that calculation. It won't do this append because it already does that internally. Oops, I just deleted that. And it won't print anything out. But what it will do is it will create a list of a list. So that's what list comprehension is. It's known as a list of a list syntax. So it's nothing more complicated than that. So if I F9 this, and you can see now that this here, this year coding errors reality, is exactly the same as this list comprehension. It takes a little bit of getting used to because the flow seems wrong, but actually if you think about it, do something, loop through something, and check if there's a certain condition. So what I'll do now is I'll do it conditional. So we're going to say, I don't know, if our yearly coding errors are greater than 500, then apply a weight. So let's say call this yearly LC, list comprehension. Let's call it CE coding errors limit, just to try and reduce the length of it down. So the start and everything else is going to be exactly the same. So what I'm going to do is I'm going to grab all this, and at the end I'm going to go if. So I'm going to go if my I is greater than or it could be equal to, or not equal to, or less than equal to, whatever, or modulo, whatever. If I is greater than 500, so what this is going to do, what do you think it might happen now? Okay, so what's going to happen is it's going to look at all those values that are greater than 500. So we know that it's only going to return a list of 2 because everything else is below 500. So if I run this now, you can see that I've got this limit variable here. So limited to a list of 2. And that's worked all in one line and allowed you to put an if condition alongside it as well. It's really, really pretty nifty. If I put I greater than equal to and press F9, I'll have a list of 3 because I've got this 500 here. Okay, does that make sense? Right. So what we'd probably do now is just move on to a few other things that we didn't cover in the last tutorial around sorting our lists, copying our lists, and joining our lists. But I think what I'll do is I'll leave that for tutorial number 3. So guys, I hope you found that useful, and I'll catch you on the other side.